Hello everyone, welcome to Chemazon-Complete Chemistry. So in our today's video, we are going to solve the fifth question of the JAM 2022 paper. So the question is, which one of the following option is best suited for effecting the transformation? So what is happening in this reaction is, in the reactant you can see this is which functional group? This is alcohol. Alcohol remains as it is. Okay, there should be no change to the alcohol. But aldehyde, this is CHO is what? CHO is aldehyde functional group. It is getting oxidized to carboxylic acid. Okay, so say this is what? This is which alcohol? This is secondary alcohol. So secondary alcohol should not get oxidized. Only aldehyde should be oxidized to carboxylic acid. So what is the name of this reaction? What we can call this reaction can be called as selective oxidation. Okay, just like in the previous question, we had seen selective reduction by using reducing agents. Here we are doing selective oxidation, which means one of the functional group remains as it is, only the second or the other functional group is getting oxidized. Okay, so these are the oxidizing agents that are given. Now what we can do, we can react the reactant with all the reagents and we can see what are the final product. Okay, so the first one is MnO2. This is what? This is manganese oxide. This is called as manganese dioxide or manganese oxide. Okay, what is the role of this reagent is? It is specific for oxidation of, it is specifically used for the oxidation of allylic. Okay, first is allylic alcohol and benzylic alcohols. Okay, what is the meaning of this? First, let us understand the meaning of allylic and benzylic. Allylic means, suppose there is a double bond and this carbon next to double bond is called as allylic. Okay, if I talk about next carbon, then this carbon is called as homoallylic. Okay, so this you can remember. So if OH is attached at this allylic position like this, then the oxidation will take place and the alcohol will be converted to ketone. Okay, if OH is present at the allylic position, that is called as allylic alcohol. For example, this is an example of allylic alcohol. This is the allylic position. Carbon just next to the double bond is allylic position and alcohol attached to the allylic position is called as allylic alcohol. If I do oxidation by using MnO2, this will be oxidized to form ketone. Similarly, benzylic. What is the meaning of benzylic? Carbon next to benzene is called as benzylic. Suppose I add OH here. This is called as benzylic alcohol. And what is the name of this compound? This is called as benzyl alcohol. Okay, because OH is present at the benzylic position, so the name of this is called as benzyl alcohol. Okay, so if I do the oxidation of this, okay, this is the benzylic position. Carbon next to benzene ring is called as benzylic carbon. OH attached at the benzylic carbon is called as benzylic alcohol. Here if I add MnO2, what I will get? Okay, this will be oxidized to aldehyde. Okay, so here what will happen? There will be no reaction. Why? Here there will be no reaction because there is no benzylic or allylic alcohol. Okay, there will be no reaction, it will remain as it is. So this is not the correct answer. Second one, here if you see, this is which reagent? DMSO, dimethyl sulfoxide, plus this is called as carbonyl COCl. This is called oxalyl chloride. Oxalyl chloride. And this is what? This is a base. Overall, there is a name of this, which reaction this is, which reagent this is called as Swern oxidation. Okay, what happens in Swern oxidation is primary alcohol is converted to primary alcohol is converted to aldehyde, and secondary alcohol is converted to ketone. Okay, so what will happen here is, this is a secondary alcohol. Secondary alcohol will be oxidized. Okay, here if I add DMSO, COCl2 and base, what will happen? Okay, this cyclohexane as it is, aldehyde group will not be oxidized and OH will be oxidized. But what we require in the final product, we require that the aldehyde should be oxidized to carboxylic acid and this alcohol should remain same. But here alcohol is getting converted to, secondary alcohol is getting converted to ketone. So this is not the correct option. Okay, what is the name of this reagent? This is called as aluminium. This is this is O, and IPR means isopropyl group. CH3 CH3. This is called as IPR, or it is also called as isopropyl group. Okay, so what is the name of this entire part? This is called as isopro, because of this isopropyl group, and then there is oxygen, so this is called as isopropoxyl group, and overall name of this reagent is called as aluminium isopropoxide. Okay, aluminium isopropoxide, and there is a name for this reaction. This is called as Oppenauer oxidation. AUER, Oppenauer oxidation. What happens in this reaction is, this is specifically for secondary alcohols. Okay, secondary alcohols, when we react with aluminium isopropoxide, what will happen? We will get a ketone. Okay, what will be the entire structure of this? There will be Al, one such group. Similarly, there will be another group like this. Okay, this is the entire structure of aluminium isopropoxide. So if we talk about our reagent given in reactant given in the question, here there is aldehyde and alcohol. So when we react it with AlOIPR3, what will happen? Aldehyde will remain as it is. Again, the secondary alcohol will be converted to ketone. But we want that this alcohol should not be reacting. So this is also incorrect. Now let us see the last one. This is what? Silver oxide and base. This is what? Tollen's reagent. This is called as Tollen's reagent, or it is also called as silver mirror test. Silver mirror test. Okay, now why it is called a silver mirror test, that we will see. So what happens here is, we have an aldehyde in presence of silver ions that we will get from silver oxide, and base. Okay, base we will get OH minus or hydroxyl ions from ammonium hydroxide. NH4OH is what? It is ammonium. NH4 is ammonium ion. OH is hydroxide. So ammonium hydroxide. So what will happen here is, Ag, it was in +1 oxidation state. Its oxidation state has reduced to 0. We had already seen the rules of oxidation state. Here charge is +1. That is why oxidation state of silver is +1. Here it is in the neutral elemental form. So that is why the oxidation state is 0. So what is happening? Silver itself, it is getting reduced. Okay, Ag plus is getting reduced. So it is what? It is the Ag, silver itself is getting reduced. So it is the oxidizing agent. Okay, Ag plus is oxidizing what? It oxidizes aldehyde to carboxylic acid. Okay, aldehyde is oxidized to carboxylic acid. That is why this is also a distinguishing test between aldehyde and ketone. Okay, we say that Tollen's reagent is a distinguishing test for aldehyde and ketone. How? Aldehyde will react, but ketone will not react because ketones cannot be easily oxidized. Okay, ketones will not be oxidized, but we can oxidize aldehyde to carboxylic acid. So what will happen in the reactant that is given to us? Here there is aldehyde and secondary alcohol. Here secondary alcohol will not be oxidized. It is specifically for aldehydes. So secondary alcohol will remain as it is, and aldehyde will be oxidized to carboxylic acid. So this is going to be our correct answer. Okay, so which is our correct answer for this question? Option D, that is Tollen's reagent. I hope you have understood all the reagents and their products. Why A, B and C are incorrect. Only the correct option is answer D. Thank you.